When you look around you, what do you see? Do you see your room, your phone? Or if you're outside, do you see trees and people and buildings? But is what you see real? Are trees really green? Do colors exist? The answer is no. The colors you see all around you are all part of your process of vision and not an intrinsic quality of what you see. But what does that really mean? How do we see colors if colors aren't even real? In order to understand colors, we first have to know what light is. Everything we can see thanks to photons. Photons are tiny particles that behave in wave-particle duality. This means that photons are both electromagnetic waves and also particles. Right now, we will focus on the wave qualities of photons. Waves have intrinsic values called frequencies and wavelengths, which are directly linked to one another. As you know from the famous equation, c is the speed of light in a vacuum. Wavelength is the distance between two exact points of a wave. Frequency is the number of full waves created in 1 second. As the frequency of a wave increases, the wavelength proportionately decreases. The lowest light frequency that we can see is red, and the highest is violet. Radio waves and X-rays are waves that we are not able to see. Now we know a bit more about light. But how do we use photons to see? Light enters our eye from the cornea to our lens, and goes mostly to our macula, which is where our receptors are. We have 3 types of receptors. Rod receptors are receptors that separate black, white, and gray. We have 3 types of cone receptors sensitive to short, medium, and long wavelengths of light: blue, green, red. The last receptor is PRGCS. They provide information about the length of day and night, helping our circadian rhythm to fit into it. They also help control our pupil size adjustment. Assume you have a red book in front of you. The reason it is red to you is that when light hits a red book, the red dye molecules absorb almost every other frequency of light, except for the frequencies around 4.62 Hz, which they reflect. That photon then enters your eye, and the long cone receptors are stimulated. The optic nerves on the blind spot pick up the information and transport it into the brain. What happens in our brain to process that information is very much unknown and full of theories. There is nothing other than our brains that interpret the specific long wavelengths of light as red. Even more, there is hardly any way to know that your red is the same as everyone else's red. If our brain perceives the information of the long cone receptors differently for some reason, we would both call it red even though we actually see a different color. This is an incredible philosophical idea. The more mind-boggling it gets is when you learn about mantis shrimps. They have 16 cone receptors and are able to see infrared and ultraviolet lights as well as polarized light. Of course, we can't even imagine any colors of ultraviolet lights. We will never know how colorful their world is. If you think about it, we are actually incredibly separated and limited from reality. What we see is not real. It is just an idea of a small fraction of the universe. We may never see the universe in any other way, and we could be the only one who sees it this way. It can be kind of depressing to learn we are intrinsically alone, but we are also incredibly unique. Every animal on Earth sees a different world. Every human might be seeing a different universe. Have a nice day.